In this video, I would like to consider two unique types of exponential equations. First, I want to solve e to the 2x minus e to the x minus 56 equals 0. This equation looks somewhat confusing, but imagine that we made a substitution here. Let's say e to the x is equal to some value u. Then I could rewrite this equation in a more familiar form. This equation would work out to be u squared minus u minus 56 equals 0. So it has a quadratic form. It looks quadratic in nature. If I was solving this for u, I would factor it and solve by factoring. I would say u minus 8 times u plus 7 is equal to 0. Set each factor equal to 0, we get u equals 8, and we get u equals negative 7. Now let's go back to our substitution. We said that u is equal to e to the x. So instead of saying u equals 8 and u equals 7, why don't we say e to the x equals 8 and e to the x equals negative 7. To solve these for x, I can apply the natural log to both sides. Because it's an equality, I can take the natural log of both sides and the equality remains. This side is equivalent to x, so I get x equals natural log of 8. That's a solution to this equation. Once again, we'll recall that natural log of 8 is a number just like any other rational or irrational number. It's acceptable as an algebraic solution. Here I apply natural log to both sides. But if we're paying attention, we'll see a problem here. We cannot find the natural log of negative 7. If you think about the properties of a logarithm, the log of a non-positive number is undefined. So there is no solution here to this equation. X is undefined. That means we're left with one final solution, x equals the natural log of 8 to our equation. For the second example, let's go back to the idea of compound interest. So we have some information here, and we are told that the interest is compounded continuously. That's a signal that we need to use this formula. A of t equals p times e to the power of rt. And I'm going to plug in the amounts that I know. So here we are given a principal amount, p equals 8,000. We are given a interest rate, a nominal interest rate, 3.5%, or as a decimal, 0.035. We're actually given a future amount because we are asked how long will it take the investment to double. If it doubles in value, the future amount will be worth $16,000. And we are being asked to solve for t. That is the unknown value that we would like to find. How long will it take for the investment to double? Let's plug in what we know. I can say 16,000 equals 8,000 times e to the 0.035 times t. Dividing by 8,000 would simplify this equation. I have 2 equals e to the power of 0.035 t. And because this is an equality, and because of our one-to-one property of logarithms, let's apply natural log to both sides. This allows me to isolate t. On one side I have the natural log of 2. On the other side I have 0.035 t. Remember, natural log of e to the power of something is equal to that something. I can solve for t by simply dividing by 0.035 on both sides. This is considered an exact answer for t. So I'm saying the time is the natural log of 2 divided by 0.035. That is an algebraic answer. However, it may not be very satisfying because we often think of time in years, and I don't really know what this is in years. So I'm going to get an approximation of this using a calculator. This works out to about 19.8 years. That is how long it would take for this investment to double.